This is Twit.
We are basically building a low-touch continuous optimization for Kubernetes that will allow developers and teams to realize the savings 10x faster and save up to 50% of their cloud bill. And we use machine learning to achieve all of that. This is what we do in a nutshell.
Tell me about machine learning. How is that impacting this?
So machine learning is engaged at different levels. The first one is rather than doing reactive kind of scalability for the infrastructure and containers, we try to do it in a proactive way. So if you're running your application, in a fairly stable environment, and you know that there is a weekly or maybe daily pattern of your usage, you want your infrastructure and capacity go with that. So let's say in the morning, 8 a.m. to 10 a.m., you get a spike, and then the rest of the day, maybe things get a bit slower. You want to make sure that you have the right infrastructure or the right capacity during those 2 hours, and you don't want to keep that infrastructure provision for the rest of the day. You can wind down parts of it and make sure that moving forward, you're efficient all the time. So being proactive on that and learning the pattern is the first part where the machine learning piece get engaged. The second part is when basically the system tries to understand the correlations between different metrics. So if I scale container number one, and that container, is going to keep up, do I need to keep up with those, users' workloads? Do you really need to scale up other containers in the background or not? So rather than for the developer or the DevOps guy to add all the rules, all the complex rules around each one of those containers independently, and then they would need to really go through them every few weeks, those rules are generated automatically and the dependencies are identified using machine learning. So that's the second part. And then the last part, think of it again as the autopilot. If the AI made a recommendation or decision that is not really right for that particular workload, how can the AI or how can that scalability really roll back and give control back to the humans or to the users? A nice analogy that we usually give it is, think of Magalix as the autopilot. Pretty much use that analogy, that kind of an example. The commercial flights, they would have the autopilot, and it's for sure the human pilots can take the whole trip end to end by themselves. But the reason that they use the autopilot because there's so many variables that they need to take care of during that long flight. And at a certain point, the human pilot does not really need to take care of or keep monitoring all of these. So the autopilot can take care of the simple stuff and reduce the cognitive overhead from whoever driving the plane or flying the plane at that time. So we're doing the same thing for cloud infrastructure. We want to basically make it easy to scale down the infrastructure based on parameters that are coming from or starting from the user workloads all the way to the infrastructure.